Welcome to the Deep Dive. Today, we're going to tackle something pretty fundamental in software development, a principle you hear all the time, DRY.
Ah, yes, DRY. Don't repeat yourself.
Exactly. The basic idea is, pretty straightforward. Spot repetition, get rid of it, use abstractions, maybe normalize data, whatever stops you from writing the same code or defining the same information multiple times,
Yeah.
especially if it's stuff you think might change later.
Right. And it feels good, doesn't it? You see the same block of code in like 3 different places.
Yeah.
And you think, aha, efficiency calling. That first visual we've got kind of nails it. Just same code, plastered everywhere. DRY says, nope, let's centralize that.
Makes perfect sense on the surface. Update once, fix everywhere. Less chance of things getting out of sync. Seems like a win-win.
It seems like it. But that's where the plot thickens. Like pretty much any good idea, you can take DRY too far.
Oh, absolutely. That well-meaning cleanup can actually sometimes create an even bigger tangle down the road.
Yeah.
So that's what we're digging into today, Vine, is repeating yourself, well, actually, okay. And maybe more importantly, how do you manage shared stuff responsibly when it does make sense?
Yeah, our mission here is really to help you, the listener, get a feel for the nuances. It's not black and white. We want you to be able to spot when maybe you're being a bit too DRY and give you some solid guidelines for sharing code in a way that actually helps maintainability in the long run. Aiming for code that's robust, easy to understand, not just superficially DRY.
Okay, let's start unpicking this. Where does going to DRY lead us astray? First up, something called premature abstraction.
Right. Sounds a bit fancy, but it's pretty simple.
Yeah, it's basically creating an abstraction like a base class or a shared function, whatever, too soon, because you think you'll need it later.
Exactly. You're anticipating a future need based on, well, sometimes just a hunch. Oh, these two things look a bit similar. Maybe they'll share more logic later. Let's make a common thing now.
That order, Connie Sett's example, is a good illustration. Someone sees regular order and express order and thinks, okay, base order, class time.
Precisely. But maybe they don't actually share that much core behavior once you get into the weeds. Or maybe a third type, like subscription order, comes along and it just doesn't fit the mold you created.
And suddenly your elegant abstraction is actually making things harder, forcing weird overrides or flags. It wasn't even that the requirements changed drastically. It was just you jumped the gun on the pattern.
Yeah, you saw a pattern that wasn't quite solid yet. So the takeaway is probably abstract based on real existing duplication, not just a feeling you might need it.
Okay, so that flows nicely into the next potential problem, semantic overload.
Ah, yeah. Thinking about domain-driven design here, that idea of a ubiquitous language is super important. Having clear shared terms within a specific part of your system.
Right, so everyone knows what, say, a product means in the context of the catalog.
Exactly. But if you try to make one single shared concept, like that enterprise product of TS example, mean too many different things across different contexts, well, things get confusing.
So this enterprise product tries to handle retail details, wholesale rules, maybe inventory specifics. It just gets bloated.
Totally bloated. It increases the cognitive load, as they say. Anyone working with it has to wade through all these properties and methods that might be completely irrelevant to what they're doing. It just makes the code harder to reason about.
You're constantly asking, okay, which parts of this massive thing apply to me right now?
Right. Compare that to the separate product.ts idea. If a retail product and a wholesale product behave differently, maybe have different data points that matter.
But maybe just keep them separate.
Yeah, at least initially. Keep the meaning clear and focused within each context. Don't overload one term. Clarity usually wins.
Makes sense. Okay, next headache, coupling.
The inevitable consequence of sharing code.
Right. You pull out that common logic, put it in a shared module or class, and boom, everything that uses it is now coupled to it, dependent on it.
And while that dependency is often the whole point, it carries risk. Because changes in that shared piece can break the code that depends on it. Sometimes, quite subtly.
The source had that great quantity.ts example. Let's talk through that.
Okay, so imagine you have a shared quantity value object. Initially, it has a strict rule. Must be greater than 0. Seems reasonable for lots of things.
Like items in a cart, yeah. Can't buy -3 apples.
Exactly. But then a new requirement pops up somewhere else in the system. Maybe for, I don't know, stock adjustments, you do need to represent a quantity of 0.
Okay, so you update the shared quantity component. New quantity.ts now allows 0. It seems like a small, sensible change.
Seems small. But then you've got other code, like that transfer.ts example that was maybe written assuming quantity was always positive. It implicitly relied on that original, stricter rule.
So allowing 0 might introduce a bug over in the transfer logic because it never expected a 0 quantity. Like maybe it divides by the quantity somewhere?
Could be, or maybe it skips a validation step. The point is, the consuming code wasn't necessarily wrong, but its implicit assumptions were broken by the change in the shared dependency, even if the shared code's own tests were updated, as shown in that second image.
The code using it might still fail because its expectations of the shared code's behavior changed.
Precisely. It's that silent but deadly kind of coupling break. And because the change in the shared code seems so minor, just allowing 0, it can be really tough to track down why something unrelated suddenly broke.
Okay, so we've talked about premature abstraction, semantic overload, sneaky coupling breaks. It sounds like DRY can be a minefield.
It can be if you apply it blindly, but that doesn't mean it's bad. The source gives some really good pointers on when and how to use it responsibly.
Right, when is it actually the right tool for the job?
Top of the list, business rules, core business logic.
Okay. Things like how discounts are calculated or validation rules that absolutely define how the business operates.
Exactly. These are the things you really don't want duplicated inconsistently. Imagine that checkout controller.ts example, where maybe the discount logic is copied into the checkout API and some batch reporting job.
Oh boy. Yeah, you just know those two versions are going to drift apart over time.
Yeah.
One gets updated, the other doesn't.
And suddenly customers are getting different discounts depending on how they interact with the system, or reports don't match reality. That's where inconsistent duplication causes real, tangible problems. That's the sweet spot for DRY.
So focus DRY efforts on core business invariants, but maybe less critical for, say, infrastructure concerns.
The source suggests that, yeah, a bit of duplication in helper functions or configuration setup might be acceptable, especially if the duplicated surface area isn't huge. The cost of creating, maintaining, and versioning a tiny shared library might outweigh the benefit of removing a few lines of duplicated code.
It's a trade-off, as always.
Always. Which loops back to avoiding that premature abstraction we talked about.
Right. Don't abstract just because something looks similar. Wait until the similarity is proven, stable, and represents a genuine shared concept or rule.
The old mantra, make it work, then make it right, kind of applies. Get the functionality correct first, maybe with some duplication. Then, once you understand the domain better, refactor to remove duplication where it makes sense.
And for OOP folks, the advice is often favor composition over inheritance, at least initially.
Definitely. Building objects by combining smaller, focused pieces, composition, is often more flexible than locking yourself into a rigid inheritance hierarchy too early. That orderservice.ts example hints at maybe composing shared logic into the service rather than forcing all orders to inherit from one base class.
Okay, what other guidelines help?
Make it small. If you do create a shared component, keep it focused. Modular.
So avoid the giant core or shared library that everything depends on.
Please, yes. Think about that third image. Instead of one global quantity used everywhere, maybe you have a quantity specific to the ordering context and another for inventory. They might look similar, but they live within their own inner boundaries.
Why is that better?
It limits the blast radius. If you change the ordering quantity, you're less likely to accidentally break something over in inventory because they're separate components. It keeps the dependencies contained.
And it avoids those massive utils packages becoming a dumping ground for unrelated stuff.
Exactly. Keep things cohesive. Then there's versioning.
Like treating your shared components almost like third-party libraries.
Pretty much. Give them their own versions, independent of the services or applications that use them, like an API contract. The version.ts example shows this idea.
And the benefit there is stability, right? My application can choose to depend on version 1.2 of the shared business rules library, even if version 1.3 is out.
Right. You upgrade deliberately when you're ready to test against the changes in the new version, rather than getting potentially breaking changes forced on you with every build.
Okay, small components, version them. What else?
Test the contract. This is crucial.
Meaning, test how my code uses the shared component.
Yes. Don't just rely on the unit tests inside the shared components repository. Those tests might pass, but they might have been updated along with a behavior change that your code wasn't expecting. Remember that fourth image?
Yeah, shared code updates, its tests update, everything looks green.
But your code, the consumer, suddenly breaks because it relied on the old behavior, the old contract.
So you need tests on the consumer side, or maybe specific contract tests, that verify the shared component still behaves the way you expect it to. Like the test.t's example.
Exactly. These tests act as an early warning system. If an update to the shared library breaks the contract your code relies on, your contract test should fail, telling you something important changed.
Got it. So it's like building guardrails around those dependencies.
It really is. So, wrapping it all up, DRY isn't a law. It's a guideline, a very useful one, but use it wisely.
Understand why you're doing it, usually to keep those critical business rules consistent.
Right. Don't just chase zero duplication for its own sake, especially based on static analysis tool warnings. Resist that urge to abstract too early.
Maybe make a note like, hey, these things look similar, potential abstraction later, but don't actually build it yet.
Perfect. Wait for clarity, and when you do share, keep it small, keep it focused, version it, and test the contract from the user's perspective.
It's really about critical thinking, isn't it? Weighing the benefits of reuse against the costs of coupling and potential future complexity.
Absolutely. Aim for code that's genuinely maintainable, not just superficially clean, according to one specific rule. The sources we looked at offer some great starting points for developing that critical thinking.
Definitely worth digging into. So for everyone listening, be sure to check out the description. We'll have links and more of those juicy details we discussed today.
Yeah, lots more depth there.
And hey, while you're scrolling down, why not hit subscribe on the Architecture Corner newsletter? It's totally free, and you'll get more deep dives like this one delivered right to you. Thanks for joining us.